highly harmful audio waves. I'm Rahul Sasi. I work as a researcher for Eyesight Partners, also known as FP on X2H. I'm a member of Garage for Hackers. I do a lot of things actually. I speak at conferences. I do a little bit of vulnerability research. A bit of reverse engineering and web app security related stuff. So it's pretty much of anything which is related to security I am pretty much interested in. Garage for Hackers, it's a community of like-minded people where we have members all across the world. We have people from consulting, research, law enforcement sharing our codes and tools. It's basically a forum which could be reached at http://www.garageforhackers.com. So today's talk will cover the following things. It's mainly on telephone-based application. How many of you in this room right now were there for my Nalcon Goa talk? So it's like less than 5%, right? Or maybe 5%. So anyways, we were actually working on telephone-based applications. So this research is a little advanced of what we were doing. So we'll be demonstrating little stuff which we were working on before, and then we will move on to the actual paper. So we will have some introduction on our previous research that was on IVRs, interactive voice response systems, building the phone banking applications and the customer support applications and all those stuff. And then we will move on to the current paper and have a little introduction on DTMF, filelcon multi-frequency systems, how those inputs are processed, where are they used, and in general how to first these applications and find bugs in it. So it's pretty much going to be fun. So a little recap on what we were working on before. As I mentioned, it was an IVR-based application. How many of you know what IVRs are and what IVR-based applications are? Right. So it's mainly used in customer support and phone banking and all those sort of places where the user interacts with the system, all by using he makes a phone call to a particular system, a computer response system responds back to him, and he interacts with the system using voice or either DTMF tone, that is using his touchpad tones, he interacts with the system. So I already mentioned this is a little, we'll cover 15 minutes, we'll cover what we were working on, then we will move on to the actual paper which we are going to demonstrate. So on those systems, what we like I mentioned, it uses DTMF as input, and some of the systems uses voice as input. So we were able to find a lot of vulnerabilities in the implementations of IVR systems, and that was already demonstrated in a couple of other talks, and in detail you can find a little demonstration on my blog. So DTMF is nothing but the tones which are generated when you press a standard phone. This is not how the GSM stack works. When you make a standard phone call on your, on the previous phones, the tone, the sound that is generated when you press one of these numbers on the keypad are the DTMF tones. So these tones are actually sent to a receiver and it processes and get all worked out. So so voice recognition systems, that is main application is internet banking and phone banking application. That was the one which was commonly used for IVR-based applications. And the main problem with these applications were it was considered secure. It was unaudited first of all. It was everywhere, and it was considered secure, and there was no firewall or capture systems in place for monitoring IVR-based applications. So there were a lot of logical flaws. There were a lot of other issues which we found. All because it was just left unnoticed. So these were the things which we demonstrated previously in Nalcon and also a couple of other places. We demonstrated how it was possible to fingerprint these applications just using a phone call. We demonstrated attacks like SQL injection and buffer overflow attacks just using a phone call and how it was possible to crash all the applications. We'll have like 2-3 demos on that. Then we will move on to the other one. So these are the things we already did. And the current paper, what we are doing is like, see, DTMF is there. Every place where DTMF is used, there has to be an algorithm, something which detects the DTMF tones. So if a tone of 1 comes, there has to be an algorithm embedded somewhere which states that the incoming tone was so and so, and there has to be something to decode it back. So the actual research is on that. So demo recap on the previous one, fingerprinting application. How we used to fingerprint this application in the previous demo was, everyone knows how to audit a web application, right? You just send it with a malicious input or some sort of junk input, wait for the response back, see if it's, read the response and see if it's, if it's got some sort of good thing in it. So, and then you can determine if it's vulnerable or not. But how is it possible to do it in IVR application? What we found was, these IVR applications uses, it reads out the output. I mean, the way it interacts back to your user is voice, right? A customer support application. So if you press the number 1, the response which is coming back to you is in an audio format. So if you can trigger errors in the system, we were able to make the system read out the errors to you. So this is a sample demo application. This is to understand how the DTMF processing works actually.
To test DTMF, press 1, or to test DTMF, please press any number key on your keypad. Looks like you pressed 5. Welcome to the Nocon SV1H2S server. To test DTMF, press 1, or to test speech recognition, press 2. Please say red.
Red.
No mash.
Red.
No. Looks like you said red. Welcome to the Nocon SV1H2S server. To test DTMF, press 1, or to test speech recognition, press 2.
So this is a very simple DTMF processing and voice processing and how the application is. So I think this explains what these applications are and where these inputs are, how the inputs are processed, right? Moving on. So these applications were built in a language called VXML and CXML. VXML stands for Voice XML, and CXML stands for Call XML. So it's very much similar to XML. The syntax and everything is similar. So VXML is used when the application needs both voice and data, voice and DTMF input, and CXML is used when the application is built only have support for DTMF input. So this is a very sample program. What it does is ask the user to say a particular word. It's got a couple of options determined over there in the grammar, like type. Grammar is equal to type, that particular column you can see banging, support and test. So these are the options which are determined there. So if the user say banging, it will be the field, see the prompt field where the banging before that particular place get executed. So if the user say support, the second module else condition will get executed. And if the user says test, it is supposed to fetch the data from a web page, which is not actually there. So this is a very buggy program actually, which if the user says test, the application will try to fetch the page from test.php and will give a response back to the user. But in the actual scenario, what was there that the user, there was no such page called test.php, and that was creating, that was causing error. You can actually see what happens when one such exception, banging.
Welcome to SV1 Bank. Have a great day. Choose an option.
Support.
Your call will be redirected to customer support. Choose an option.
Test.
That content is not available at this time. I couldn't find a web page. Error starting voice XML application. Failed fetch with code 404. Not found. URL http://19990.19990/test.php. That content has an internal error. Error starting voice XML application. XML parse error. S. Occurred in http://127.0.19990/.
So it will pretty much, so if these sort of exceptions are, you can trigger these sort of exceptions, the application will pretty much read out the entire stack for you. You can figure out the IP address, you can figure out a lot of information from it. So these are all just to make you aware of what we were doing before and how these applications work. And yeah, and we also demonstrated buffer overflow based attacks actually, where when you know if the application the backend is built in a C or anything related to that, and the application accepts the input from the user and passes it on to the program running in the backend without any sort of validation, we are able to crash a remote stack just using DTMF clones. So that is the demonstration actually. So this was a very buggy program which takes input from the DTMF interface and just passes on to a vulnerable program like this C, where it's got a overflow at the line, at this particular line. So when a long string of DTMF characters were received, there was a crash. And what is HTTP error code 500? Internal server. That means either the server has crashed or anything which is related to that. Let's see what happens when you run.
Please enter your PIN. Please wait while we process your information. Sorry, that content has an internal error. A web server error occurred. Error starting voice XML application, failed fetch with code 500. Server error, URL, http://192.168.43.97/cg.
So all these things which you saw right now, those are application related things. So that is like those were the flows that occurred because of the VXML. There was like core to VXML application was due to the implementation of VXML buggy codes. So what we started thinking was, fine, there is an application level bug. How does these systems detect DTMF? So that means when I send a DTMF from one to one of these systems, how does it understand that the tone which came is one, and how does it convert back to the numerical format? So we started analyzing that particular implementation. I mean, different implementations, reverse engineering, a lot of things. So, in short, DTMF, the tones are used in this following application: IVRs, which are used in customer care, customer support applications, phone banking, PBXs that are used in telephone systems and voicemails, VoIP systems. So these are the places where DTMF is used as an input. And there has to be a mechanism which decodes the input which comes to the end user and converts it back to the numerical format. So, imagine the power you have if you are able to find an exception in these algorithms, this DTMF detection algorithm. You could possibly remotely crash a customer support application using few tones, or you can shut down an entire phone banking just using a phone call, sending a couple of DTMF tones. That is finding problems in the detection algorithm. Or like consider you can shut down a telephone router which handles thousands of calls, and if you're able to remotely end that particular thing using few payloads, it will be very, very bad. So we started digging more. What we found, and the very common algorithm which is used for DTMF generation, I mean, actually there is a DTMF generator which generates DTMF tones, and there is a detector which decodes the DTMF value, right? So the algorithm called Grossetels, this is the algorithm which is commonly used in almost 90% of the implementation of DTMF detection, and it's almost used in all the applications. So this was the application we will be, this is the algorithm we will be digging more into. So let's see what DTMF, why is it called DTMF, and what exactly DTMF is. DTMF stands for dual tone multi-frequency. So when you press one of these numbers on the keypad, on the phone pad, the tone which is generated are the DTMF tones. So the ones which you heard already. So why is it called multi-frequency? Because the tones are built based on two different frequencies. That is a smaller frequency. You can see horizontal and vertical table. So it's a combination of two different frequencies. That means when I press the keypad 5, a frequency of 770 Hertz and a tone of frequency 1336 Hertz is produced simultaneously. And these tones combine together to form the representation of digit 5. So same goes with if I press 0, a tone of 941 Hertz and a tone of 1653 Hertz is produced simultaneously to produce the representation of the tone D. So that is why it's two different frequencies, so multi-frequency, and it's a combination of high frequency, that is the horizontal and the vertical taps. So this we already explained. So I'll show you a small detection. I'll show you a small program which does the detection. DTMF generation. Yeah, so over here you can see this is a small C program to generate DTMF tones. So over here you can see the lower frequency tones which I mentioned, 941, 697 to 941, and the higher frequency. And then what we do is produce both the tones simultaneously. So whenever someone presses something, these two tones of these two frequencies are produced simultaneously, and it's sent, and those form a tone actually. Let me see. I'll show you a small example of the generation. For EC, we have made it in PHP as well. So this is another program which the same program, it's in PHP. And this one is in C, so it's all the same. I think you understood the concept, right? The generation concept. Is it clear for you, everyone? So that is pretty much. It's very simple. Just produce two different tones of two different frequencies at the same time, and just that is it. That is the representation. But that is the easy part. Generation is the easy part, but the detection is the hardest part. And that is the reason why I use the algorithm called Grossetel's. So we'll go in detail of Grossetel's algorithm. It's a DSP function. It's a digital signal processing function. A lot of mathematical computation takes place over there. A lot of sine, cosine values. A lot of mathematical computation takes place when this algorithm actually, executes. So, how many of you are from the DSP background? DSP, right? So, it might be a little hard for certain things. Might be a little hard for people from non-DSP background, but so it's a DSP based function. It uses a lot of mathematical computation. It's one of the, as I already mentioned, it's one of the common most algorithms that are used for DTMF detection. It computes a sample, it computes a sequence of using DFT. 16 samples of DFT are used to compute 16 tones. So all the 0 to 9 and A, B, C, D tones, it computes using 16 samples. We'll just we'll go in detail about Grossetel's algorithm. So this is the actual equation that is used to detect the tones. So a tone comes, this mathematical computation is what happens when each tone comes, and this value determines what is the input which came. To make it simple, we have to determine K, the value of K determine which was the ketone which was pressed. K is built using N is actually a constant, into F tone. F tone is the frequency, input frequency, the frequency of the tone which came in, divided by the sampling frequency. Sampling frequency is nothing but what do you call? F of S is like the time individual tones are, the time which is there individual tone persists. So so once we fed these inputs to our equation, we'll be able to generate k will get a particular value, and that particular value of k is used to determine what was the tone which was pressed. Is it clear, or are we going fine? If you're finding any sort of problems in following, I'll be able to, just let me know. We'll be able to go accordingly. So this is the input which is used. So this is a table. So once k gets one of these table, k, the computation of k. So this is the table which computes the k, and coefficient. Actually, you see the coefficient decimal. That is the table which the value which actually k gets. So one of those values are actually used to determine which was the exact number which was pressed. So it is actually a bit confusing, but it'll become more clear in the coming. So this is actually a pseudocode. This pseudocode will be almost there in all the implementation of the DTMF. It'll be embedded in almost all the system which has got DTMF in it. So this is a very pseudocode that is used to compute the values. Go more. Okay. So over here, the thing is like we can fuss anything. Fuzzing is like you can fuss anything. All you have to do is a user control input, right? Over here, just tell me what all things a user controls. An application which interacts with a DTMF processing algorithm as a user. This is the equation that is used to process it. What all do we control in this thing? Yeah, FS and F tone is something we control. It's the user has control. You can generate what an FS and F tone of different variable and varying length frequencies or varying variables, and that is something we can use to fuzz. I'll show you a pseudo code. So I'll show you a small PHP. It's a generation tone. Okay. Okay. So yeah. This is the samples per second, that is FS, that is how much samples should come in a particular cell, like 222 should be like the frequency, I mean the what do you call, whether I should process 3 samples at a second or should process more than 3 samples at a second is what determined by f of s. And then we have, can you see the, is it possible to see the code, I mean the source code in the back? And then we have, that is f of s, that is something which we control as a user, you control f of s. Then you control the signal length, how much milliseconds a tone has to persist. That means it has to be toop or toop. So that is the value which signal length, that is also you control. The backend system has to process that. Then the break in milliseconds, that means how much seconds it has to pause after another signal is coming and how much seconds it will take to process that. So that is also something which we control. So we have like 1, 2, 3 as of now. Then we have amplitude. Amplitude actually is also something we is also a user control variable. We'll start showing how when you vary these values, what happens. We'll show signals in milliseconds. We'll increase the signals in milliseconds to a different value. It's getting very annoying, right? So you have to understand the application which processes it, how much more annoying it will be for them, I mean the application. So this is what happens when you vary this is what happens when you vary the f of s value. More down? Okay. So, and yeah, so, and we'll go back to break in milliseconds, should be less. We're going to put it like 50 milliseconds. So that means the tones will start, or maybe 10 would be great. And this milliseconds, pause in milliseconds actually. Amplitude. So what actually happens is, this is a small video of what actually happens. So this is a very traditional detection algorithm which will wait for the input tones. Actually, the tone is the video recorder which I used. It was not able to record the sound actually on the screen. So I'll show you. So what actually happens is, when we tested it on a lot of our own production, I mean our own internal test machines, these algorithms were not able to handle. We will release the fuzzer actually. These algorithms were not able to handle the varying frequencies, the varying fuzz input, and it was able to see the CPU rate of the detect underscore CPU function. This is currently running on a it's an Intel 4 or 8 GB RAM and with 4 CPUs, and we were allocated one CPU for this process, and the entire CPU was getting utilized when it was receiving a variable, of these sort of fuzzing input. Actually, there was a sound also. I mean, these these same sounds we are setting into these detection algorithms, and it was not able to process when we varied all these things which we mentioned right now. Let me see one more thing. Amplitude, signal length, sample per rate. Anyways, so the main thing is like the incapabilities of these systems. So what are the consequences actually? So if we'll release a fuzzer, you can actually test it on the production applications which you have. So consider an application, live application which is running, and the user has direct access to send these sort of tones to an application, and he constantly run one of these fuzzers on the application. You can make the system unstable, or you can just knock out the system. Most of the cases we saw the program was breaking, and majority of the time it was just a CPU going up, but some cases we were not able to reproduce the cases actually. It was actually crashing the entire program. So in short, the giveaway is like you have to run these fuzzers on the application which uses DTMF if you have one of those, run it on a test environment, see what happens, and that is pretty much it. Any questions? We'll take some questions if you have any.
Is there a way to scan even range of phone numbers and look for IVRs?
Actually, I mean, I haven't done anything related to that, but yes, it would be possible. If there is a system which is there on the premises or not, like that. Actually, I haven't really tested this particular thing on a production system, but some applications, some main application which was using this system, we tried it on them and it was vulnerable, but we are not disclosing what the application or the name of the application.
Okay.
But what you asked is something in a pen test scenario, is it possible to scan an entire IP range and see if one of the systems are...
Conventionally, you will be scanning like IP addresses in case of a pen test, but in this particular case, you will have a set of phone numbers,
yeah, right.
where you first need to detect the IPRs.
See, previously, there was a brute force program which we released some time back. It was a Python program. The same program can be modified to do the thing which you just mentioned right
So
now.
that
Yes,
will
it is possible.
mostly involve DSP kind of thing to check the response from the
Actually,
number.
the thing which we made, it has got the capability. It was actually to do a brute force, but with few modifications, this thing could be done. You can actually detect the systems in the premises.
Okay.
But mainly, what I see is like, if there is an application in the premises, these people should at least tell you that this is there, because this is a main application which is exposed to the public, right? If it's internal, it's fine. If it's exposed to the public and the external users has got access to it, yes, then it will become more critical.
You could actually do an entire credit card scan, right? You could do fuzzing. You could start with, you anyway have the first 4 digits or the last 4 digits. You could actually do a brute force scan.
Actually, the brute force thing we already demonstrated before. If you want to see the video again. This was actually, what the question was actually, can't we just do a direct brute force attack on these sort of systems? This was something we demonstrated before. We were actually able to easily brute force, actually almost all the banks in India, there's no proper brute force mechanism for IVR application. This we already showed last time in Goa itself. Just because you asked this question, I'm just showing. This we already reported to one of them, and then actually there are a lot other people who are using, but it's like you can't go to individuals and say that this is actually another credit card number which you just mentioned, followed by this is the phone banking application, the real world application. Any questions? We'll take some questions if you have any.
Is there a way to scan even range of phone numbers and look for IVRs?
Actually, I mean, I haven't done anything related to that, but yes, it would be possible. If there is a system which is there on the premises or not, like that. Actually, I haven't really tested this particular thing on a production system, but some applications, some main application which was using this system, we tried it on them and it was vulnerable, but we are not disclosing what the application or the name of the application.
Okay.
But what you asked is something in a pen test scenario, is it possible to scan an entire IP range and see if one of the systems are...
Conventionally, you will be scanning like IP addresses in case of a pen test, but in this particular case, you will have a set of phone numbers,
yeah, right.
where you first need to detect the IPRs.
See, previously, there was a brute force program which we released some time back. It was a Python program. The same program can be modified to do the thing which you just mentioned right
So
now.
that
Yes,
will
it is possible.
mostly involve DSP kind of thing to check the response from the
Actually,
number.
the thing which we made, it has got the capability. It was actually to do a brute force, but with few modifications, this thing could be done. You can actually detect the systems in the premises.
Okay.
But mainly, what I see is like, if there is an application in the premises, these people should at least tell you that this is there, because this is a main application which is exposed to the public, right? If it's internal, it's fine. If it's exposed to the public and the external users has got access to it, yes, then it'll become more critical.
You could actually do an entire credit card scan, right? You could do fuzzing. You could start with, you anyway have the first 4 digits or the last 4 digits. You could actually do a brute force scan.
Actually, the brute force thing we already demonstrated before. If you want to see the video again. This was actually, what the question was actually, can't we just do a direct brute force attack on these sort of systems? This was something we demonstrated before. We were actually able to easily brute force, actually almost all the banks in India, there's no proper brute force mechanism for IVR application. This we already showed last time in Goa itself. Just because you asked this question, I'm just showing. This we already reported to one of them, and then actually there are a lot of other people who are using, but it's like you can't go to individuals and say that this is actually another credit card number which you just mentioned, followed by this is the phone banking application, the real world application. So it is already there. We have already released the code also to generally audit these sort of applications. Can I have a mic here? Over here.
I have two questions for you. One is, generally IVR require multiple information for financial transactions. So in a one transaction you can get the credit card number, for another the same one, to map it, you have to fuzz it. So the complexity of
actually IVRs are different. That is actually an application level, right? The paper which we demonstrated is actually not on IVRs. IVRs actually build on CXML, the VXML code. This is something which is there in almost every application. Any application which uses DTMF input or anything which can process DTMF is what we demonstrated today right now. So IVRs is just an application. It's like just calling, it's just a PHP application or any sort of application. But the DTMF processing algorithm is there in telephone routers. It's there in PBXs actually. So it's two different things. One is application, one is in general, which is there in almost everything. So we can fuss a lot of things with that particular same logic.
Okay. Another one is, do we have any simulator on this? You can try it, you can test it.
A stimulator, yeah, I have made one actually. Yes, I wasn't planning to share that, but yes, I can do that. And other stimulators, you can actually download any commercial tools. You can download any commercial IVR application and test it on them. That is possible. Or I have made a stimulator and a detector and a fuzzer just for testing out things. I'll be releasing that. Yes, you can actually do work on that. Yep.
I was just wondering, you are using a code to generate DTMF signals.
Right.
Can't we use simple DTMF boards which are available cheaply in the market to generate those codes? That will be a much easier
DTMF
solution.
boards in the sense, can you? I don't know what. DTMF.
They are cheap DTMF chips, DTMF interfacing boards which you can connect serially to your laptop and generate
Are they
those
chips?
codes. They are DTMF boards. They are
Boards, okay, boards.
They are
okay,
DTMF
okay.
boards
Boards, okay.
with an onboard DTMF encoder
I mean,
or a decoder, whatever.
Why do you want to
purchase.
buy something when you can program something in like 2-10 minutes? I mean, why do
See,
you?
anyways, you'll be sending the signal over a GSM network. Matlab, you cannot send it from your laptop
No.
to a IPRS or
GSM
PPA.
network, it's a different. I mean, in GSM network, they don't actually send the entire tone. They send it in a different way.
Yeah.
You have.
They- So when you are trying to get into a system of say Airtel or any other big brand, they are not an IP based system. They are a PBX
Yeah, right,
channel,
right.
So you need to route your system into that. So you will be requiring a modem or something
Modem is
which can
needed.
communicate to
Yeah,
that network.
modem
right?
is
You won't be
required.
able to connect your laptop and your IP address, and it's not like a IP and a port based system where you can throw in your DTMS, right?
Right,
It's
right.
a hardware based system.
Right.
So, and trust me, using a TTMF board is much more easier. Encoding and decoding is much more simpler than writing a code for it.
I don't know.
It's
At the
simple
moment,
serial inputs. matlab,
At this
one
moment,
or-
I don't really know if I mean which is right, but when you can do something in program which you can easily do in a
and,
program, I don't really understand.
yeah,
the necessity.
generating a DTMF tone is very much simple.
The
I accept
necessity is
that.
you need a modem, but that is a requirement you anyway will have. You anyway will need it, right?
Right.
Generation, I mean, it's
So even in that video which
and
you
that's
showed,
the board which will let you do varying all this fuzzing which I mentioned right now.
exactly,
all the-
exactly. That board allows you, gives you all those capabilities. That video which you showed was routing the signals through a mobile phone.
Yeah, right.
It was using 80 commands and generating those DTMF codes.
Yeah.
So you can actually you buy those cheap 20 buck boards. You just roam around Chandni Chowk or Lamington Road in Bombay. You'll find thousands of them.
I never worked with that, but yes, I'll consider that as an option
That's-
actually. If people are more interested in the hardware part or like they find it more familiar.
Exactly.
Being a
exactly.
software guy, I was more comfortable with this. Yes, but yes, that is an option actually.
Right.
Maybe someone should try it out. Actually, bidding has started. 20 million from my side. 5 million. Yeah.
I'll talk from the application point of view as a developer. Okay, you pointed out that the variable signals can be passed through the
Yeah.
DTMF decoder application. Okay, so my question is this vulnerability possible? Is it some kind of a design logic that?
Yes,
that-
yes. It's an implementation flow actually. I mean, if you are secure coding is not a future, right? It's something the developer has to put it in. If the developer who built these embedding devices was not really clear or he was not really good enough to understand that something like this is possible, yes, then it is vulnerable. In short, I'm not at all saying that this is a general vulnerability which will affect every system. So actually, there was 2-3 articles already out there. I mean, media picked it up and they boasted it as if like this is a general vulnerability which will affect every system. No. If your system is affected or not, you will have to figure it out. I'm not in a position to tell that it's a general vulnerability.
From developer's point of view, the modulation frequency is set.
Yeah.
For example, the sinusoidal. Okay, we have that the sine wave.
Yep.
I'll just put it to basics. Okay, so the amplitude signal
Yep.
is set. Okay, so it's just like when you program, when you know that okay, these are the possible inputs. Okay, you can code something which is like a simple switch case program, switch case and final. Okay, so yeah.
The actual detection, I actually didn't wanted to go in detail about the detection because then again, when we release the paper, you can read it out because it'll make it more boring to explain the entire, DTMF. See, this is actually a big program. Actually, the computations are a lot of computation, and there are like lot of arrays and things which fetches values from the audio waves and just put it and pass it in. So, I mean, I didn't want to go deep into that because when I release a paper, you can read it out. It would make the presentation more boring, explain the entire logic. But in the codes which we reviewed, yes, there were possibilities, like there were buggy programs actually. So it's more of how the developer has built it. It's not about I understand your question, yes,
this
you're right.
varies from application to application and
Yeah,
not
right.
exactly. So
Yes,
my
yes.
point was that algorithm is not the exact.
No, algorithm is not a float.
Algorithm
It
is
is the
perfect.
implementation of the algorithm that is
Exactly.
float. Yes.
Okay, that's what my question was.
I think we are out of time. That was me or you? Me? Okay. I'm ready to take questions afterwards. Just come talk to me. We can discuss more on this. Thank you.
Thank you so much, Rahul Sasi.